Alright, today we are going to present about our presentation, which is case study 2 about foam rolls and our product is the packaging. So this is our group member. I'm MUHAMAD and MUSTAQIM, and I myself MUHAMAD MOBIN, and other group members is LEONG, NURUL, LIYANA, and ALIA, and lastly CHEN. Okay, for the first stage in material selection is the strategy. So I'm going to present about the material selection strategy. First of all, we got all the materials in the world, and then we have to translate the design requirements, which is the objective and etc. So, and then we're going to screening using constraint on the translated requirement, and then after that we are going to rank the materials so that we have the one type of material that we want, and lastly we document the materials. Right. So this is the translating design requirements. So for our product, it's required, its function is to add extra protection to the product for the transport. And then their constants are thermal insulation, waterproof, lightweight, chemical resist, and shockproof. So the objective is to minimize the cost. And lastly, for the free variable, of course, we have the choice of materials. Right, next. So for the screening process, we have 5 types of material, which is polypropylene foam, polyethylene low density foam, and polyethylene high density foam, and polyethylene foam, lastly melamine foam. Alright, these are the screening of the data that we have from the CES EduPack, and these are the attributes. Alright, so we move on to the next, which is the ranking. Based on the last slide, here we can see that the polypropylene foam has the highest total marks, which is 45, compared to the others type of materials which are above average and not achieve what we have to pick. So as you can see, the choice of material is polypropylene foam. Right. Then we have to document the product, the materials that we have chosen. And the polypropylene foam has been chosen because of the lowest cost, and it has heat insulator, and it has above 100 high service temperature, and it has waterproof, and also chemical proof, and lightweight. Within all of these attributes, we can conclude that polypropylene can be used as our polyfoam for the packaging.
Okay, for the manufacturing process selection strategy, first we have to obtain the estimate of the annual production quantity, which means that we have to estimate the production quantity that we want to make. Number 2 is choose the material type to satisfy the product design specification. So the material type that we will use is polypropylene to make foam rolls. So number 3 is refer to selection of material table to select candidate. Number 4, consider each material against the engineering and economic requirements, each as understand the process and its variation. So for foam rolls, we have to understand the process and which variation to process the product. Consider the material capability. Compare tolerance and surface finish requirement with process capability data. Number 5, we consider the economic positioning of the process and obtain component cost estimates for alternative. So which did this is one for we want to estimate for the cost that we want to make. Number 6, review the selected manufacturing process against business requirement. So this is like to compare against the business requirement for other process. Okay, so this is the flowchart. First, we start from the product design specification (PDS). Obtain the relevant process selection input such as annual production quantity, material type, thickness, and permanence. So we go to design data. Okay, after that we choose we select the candidate processes, which is the processes we have is form extrusion, injection molding, and batch forming. Then we go to list of candidates and consider against technical and economic requirement. This is for. Then we go to the business factor, which is obtain component for assembly cost, estimate for candidate solution, and we go to select final processes based on quality, cost, delivery, and business strategy. Then we go to selected processes. Okay, for manufacturing process selection strategy, for the process we will translate the design requirement first, which is function, constraint, objective, and free variables. Then we use it to screen using the constraint, which is the constraint is lightweight, thin material, adsorb, liquid, and thermal insulator. Because there are not many processes that can be done for the materials such as polypropylene, polyethylene, and polystyrene. And then we ran using the objective, which is to minimize the cost and maximize the quality of the product. Then we seek for documentation. Seek for documentation is what reason we use the processes. Then we choose the final process charts. Okay, for the screening table, we have injection molding, form extrusion, and batch forming. So the skin layer thickness, we have form extrusion is thin and batch forming is thin, better than the injection molding. The density range is injection molding and batch forming is more lighter than form extrusion. Surface quality is generally poor for injection molding, and form extrusion is good and glossy, and batch forming is good. For amount of material needed, we have injection molding and form extrusion is large amount, and batch forming is just only small amount. So for the total, from the ranking score, screening score, we have form extrusion total of 3, batch forming is 2, and injection molding is 0 because it is not suitable for injection molding to process the polypropylene. And form extrusion is the most suitable to process the foam rolls for polypropylene. Okay, so the ranking is based on the screening result. The ranking of the process is as follows, which is form extrusion, batch forming, and injection molding. So we pick processes of form extrusion because it is suitable other than batch forming and injection molding.
Okay, this is the non-metallic process to form foam rolls for protective packaging using foam sheet extrusion machine. So the processing parameters that involve are shape, size range, tolerance, roughness, minimum batch size, specific heat capacity, pressure, layer thickness, cost, foam rate, thickness of product, cooling mode, and weight. And this is the diagram, the picture of a foam sheet extrusion machine. And then the materials involved are polypropylene granule, colorants and UV inhibitors if needed, talcum powder, and also butane as the forming agent. And then this is the procedure to create the foam sheet. So in the processing of the plastic raw materials through the extrusion process, the raw thermoplastic material is fed from the hopper, top mounted into the barrel, which is part of the extruder. The raw material is a polypropylene granule, The polypropylene can be mixed with various additives like colorants and UV inhibitors to enhance its properties. Then through the feed throat, which is the opening near the rear side of the barrel, the materials enter and reach the screw. At the same time, the barrel is also heated to the required melt temperature of the molten plastic. The temperature can be within the range of 200 degrees to 275 degrees, and it depends on which polymer is used. And additional heat also can contributed from the intense friction and pressure that takes from that happens in the barrel itself. And then when the molten plastic reaches the front of the barrel, the molten plastic leaves the screw and moves through a screen pad for the removal of contaminants present in the melt. Then a breaker plate is used to reinforce the screen. Breaker plate is a thick metal plug that has many holes drilled in it. And then after the molten plastic passes through the breaker plate, it enters the die, where the die will provide a specific profile for the final product, and it must be designed in such a way that the flow of molten plastic is uniform to form a cylindrical profile for the product's profile shape. After that, the product is cooled by the cooling rolls, and then the foam can be rolled into a coil and trimmed accordingly, and then transferred to the packaging process. Okay, so this is the flow chart with description showing every step of the production process of the foam roll. So we start over here and then we end it at the warehouse entry.
I'm going to explain the effect of render on product performance. The process using is a die extrusion, which can the effect of the parameter is the die axis is stability. Usually by shark skin or alligator hide. The outer surface of the part is rough. And the next one is orange curve. Defect in the surface of an extruded in which a small dimple are formed. And then the next one is part dimension control. The geometry of the die is the major influence on affecting the part size and shape. Important phenomena that occurs in this region is the die shear of the size. And die shear result from recovery of the elastic deformation as the extruder lifts the die. Next one is the streak or lines. The die use 30 and the imperfection in die, and die slips out of adjustment. Next, I'm going to talk about testing and quality control. To testing the product, there are two methods. One is free-fall drop test, and another one is shock test machine. These two methods is used to determine the shock absorbing of form in place packaging material. The one is just to test the product whether it can absorb the shock or not. How is the efficiency of the product. And then the next one is quality control. Quality control, the packaging, there are several easy packaging checks you can perform during inspection. And then check sealing methods, carton drop test, and check for compliance with material and brand packaging requirement. And the last one is wearable container.
Okay, so this is the type of defect and countermeasure. Okay, for the defect and how to control, the packaging inspection before shipping is vital to catching defect related to packaging. Okay, this is because after we pack, we want to ensure that the packaging is always secure, that it's safe to deliver to the customer. So for the problem is poor roll formation, it is too tight. The possible causes is selection of soft, easily stretched materials such as thin lightweight foams, and inconsistent moisturization. So the possible solution is select product with different combination of adhesive and optimize detention, control and moisturization during adhesive coating.
Okay, so for conclusion, the first one is to pick the material to be produced and do a selection of material strategy to form the foam. The second is to know the behavior of each material to produce it. And finally, the manufacturing process must be suitable to the product that we want to produce, which is the foam.